So now that we're switching from the New Relic APM to the FusionReactor APM for our Lucee CFML servers, I wanted to take a look at the API exposed by the FusionReactor Java agent, this FRAPI class, so that I could see how I can go into my application and add some custom instrumentation. The custom instrumentation is not super well documented. A lot of what I have here is based on one blog post that I found on the FusionReactor blog, plus actually looking at the FRAPI Java docs. So hopefully I don't get anything too wildly wrong here. But essentially, once you have the FusionReactor Java agent installed, you can access this FRAPI factory class from which we can get the current instance of the FusionReactor API. And let's just walk through this code. Essentially, what this demo does here is it attempts to simulate a feature flag and some branching in the logic based on that feature flag so that we can compare the performance before and after the experimental feature flag. So first thing we do here is set the transaction application name. Again, out of the box, FusionReactor will actually just use the name associated with the application.cfc, the Cold Fusion Application Framework. I'm setting it here just as an experimentation to see how it works. Similarly, I'm also setting the transaction name, which again, FusionReactor will pull out of the current request, even if you're using something like Framework 1, which is what we use at work, or Coldbox or FuseBox. FusionReactor, one of the best things about FusionReactor is that it's a JVM APM tool, but it's built with an eye towards the Cold Fusion community, which means that it has inherent with it some compatibility with common frameworks like Framework 1. So it will actually look at the framework action and use the Framework 1 associated action as the name of the request. But again, for this demo, I'm just using the transaction name to override. Here we're then using rand range to simulate a feature flag selection targeting. I'm using this trace method to just add some additional metadata to the transaction. Here you can see I'm tracing a string, an object, and an array. And again, I'm just trying to figure out how all of this stuff works. We're then going to take a timestamp here so that we can do some timing metrics around the feature flag. Here's the experimental case for the feature flag. Here's the else case or the base case for the feature flag. And then within each branch here, again, just tracing some more information. Here I'm getting the active transaction, which is the transaction associated with the current request, and I'm calling set property on it, which allows us to store string values, and it can only store string values from what I can see, with the current transaction, and we'll again look at how all that works. I'm then creating a sub-transaction to time this area of the code here, and of course I'm just simulating some algorithms with sleep. I'm creating another sub-transaction here. This is heavy processing start, heavy processing end on the experimental branch. In the base case, the non-experimental branch, you can see I'm doing basically all the same exact stuff. Here I'm using the base name here instead of the EXP name for my sub-transactions. Then we get the duration of the entire experiment, and we can log that as an aggregate metric in FusionReactor. And I'm looking at both the standalone dashboard as well as the cloud dashboard. And for metrics, we actually have to enable the sending of certain metrics from the standalone dashboard to the cloud dashboard. And then this is just a JavaScript timeout here to refresh this page every 1,000 milliseconds or every second to get some traffic going in the dashboards. Okay, so let's now just walk through this code again, but look at the actual dashboards to see what's going on. So the transaction application name and the transaction name, if we jump over into the dashboards here, if I go into the transaction history, you can see that we have our app name and our transaction name. That gets used a lot in the application. Here you can see it's the FRAPI testing and the get feature flag test, and that's what this is using here. But again, if I didn't have these, everything would work based on the application.cfc and the various frameworks that FusionReactor supports out of the box. Now the tracing adds metadata to the request as sort of an aside to the request itself. So if we come in here, so this is the cloud dashboard, and we're looking at our transaction history, and I jump into one of these transactions, well, you can see that we have a traces tab here. And if we look at the traces tab, here's that tracing data that I got. Starting experiment, here's the struct that I traced, here's the array that I traced, and then some other parts of the request itself. And you can see that these are all time-stamped. So essentially you can see the relative timing of the various traces, but you can see that the traces really aren't intermingled alongside the rest of the request. If you really want to intermingle timing data with the rest of the request, that's where we're going to use our subtransactions, which we'll look at in a minute. The Traces tab seems to only be available in the standalone dashboard. I could not find this information in the cloud dashboard, no matter where I looked. Might be here, but I could not find it. So let's keep going here. So then we're going to get into our feature flagging. Again, we have that trace, which we saw here, right? Starting experiment. Oh no, starting, oh, well, this is the default case. This is the experimental case. Anyway, taking a look at the transactions now, the sub-transaction. Sorry, I'm getting myself confused. This is getting the active transaction, which is currently the parent transaction, and we're setting a property. This property just shows up in the Properties tab here, and you can see this is the Feature Optimizations Test, set to false. Here it's set to true because I'm looking at a different transaction. I'm looking at the one down here where it's set to false. So set property, kind of like the tracing, allows us to add arbitrary data along with the request to transaction. This is something that I would normally use to say associate a user ID with a particular request after they've authenticated with the application. Properties are available in the standalone dashboard. They are not available in the cloud dashboard, and I have confirmed that with the FusionReactor support, at least at the time of this recording. All right, continuing on. So now we're going to start to segment the processing of the request. To do that, you can either use create transaction or create tracked transaction. Both of them create sub-transactions. The difference between create transaction and create tracked transaction is that only the tracked transaction will give you activity graphs in addition to the actual transaction data. And we'll look at that in a second. These things are pretty cool. They have to be started and they have to be explicitly closed. I assume if you don't close them, or if something here throws an error and you don't have a finally block, they'll just time out eventually and completely distort how long it took to run a transaction. But these can be seen, let's go back to the cloud dashboard. These can be seen under the Relations tab of the current transaction. So here you can see I have my overall web request, and then below that I have my heavy processing base start and my heavy processing base end, right? And actually let's just jump down to the right block here. So here's my base start transaction and my base end transaction. And both of these are just starting, sleeping, and then closing to simulate some processing there. So this is pretty great because it's really clear how that particular segment of the code actually interleaves with the overall request. And then you can see you get the kind of hierarchy of the requests here and some roll-up data as far as those transactions go. Now, because this is a tracked transaction, it means that I think that means that we can go into the activity graphs, and it's also expressed here, right? So we can see, sorry, I'm on kind of a smaller view here, but we can see here the activity, right? So this is the number of requests per minute, and then we can jump over here to the time graphs and we can see the actual duration of those segments, those sub-transactions within the parent transaction. And I think if you don't do the tracked, you can still see them in the transaction histories and everything, but you can't see them in the activity and time graphs. I'm not 100% sure on that. It was a little bit confusing to me. I did some testing where I used the different methods, and I think that's what I came up with. Now, in the cloud dashboard, it's all the information's there, but it's a little bit different. So if let me just go graphs and then go back to make sure we have live data here. If I look at a transaction, whereas it shows up in the relations data of the standalone dashboard, in the cloud dashboard it shows up under tracing, and you can see here it's very, very similar. It shows the relative execution of the given transaction in relation to the parent request, again making it very clear how long each segment within the code took. Also, like the standalone, we can look at those transactions on their own, So right now I can go into flavor and I could select, say, for example, these are just the base start transactions. So if we jump in here, again, this doesn't have a parent request because we're looking at the actual segment itself. We're looking at the actual sub transaction. So we can look at that just like we looked at, let's see, actually we can do it here as well. We can see start, right? So we can look at these transactions individually. So you can get at them both from a hierarchy, but also from the individual layers as well. Now, one thing that's really cool in the cloud dashboard is if we go into metrics, so where we have, here we can see our web activity and our memory and our CPU, we can actually look at our sub-transactions in relationship to the memory graphs and the CPU graphs, which is pretty awesome. So for example, I can come in here and now I can look at my heavy processing base start sub-transaction. And you can see here I have the request per second and I have the time, and now that's being graphed directly against the memory and the CPU. So what I can do then is look at the, if one of these times spikes, for example, or the activity spikes, and then all of a sudden there's a spike in the CPU and a spike in the memory, maybe that's an indication of that's where that processing bottleneck is coming into play. I couldn't quite figure out a way to do the same thing in the cloud dashboard where I get the graphs. You can add custom graphs to this using this metrics section, but I could do it with metrics a little bit. I couldn't quite figure it out with sub-transactions, so maybe I'm still trying to figure out how that works. All right, so what else can we do here? So I'm timing this. So in addition to creating these nested transactions, I'm also, you'll see getting the date stamp here, and then at the bottom I'm getting another date stamp, and I'm taking the diff for the duration, and then I'm actually recording a metric for this as well, so that we can again see the various performance outcomes based on the experiment or the base branch. There's a bunch of different metric methods on the FRAPI that help you deal with different data types. In this case, I'm using a numeric aggregate, so there's metrics and there's aggregate metrics. They both record values. They'll both give you a live view of the metrics, but only the aggregate will give you the hour, the day, and the week roll up. And then by default, metrics are only visible on the standalone dashboard, but if you want to stream them to the cloud dashboard as well, you have to explicitly enable the series ID, which you can see is just the same thing here. Now, the cloud dashboard can only use aggregate metric values, or sorry, it can only use numeric aggregate metric. You can't send non-numeric and non-aggregate values to the cloud dashboard. So these show up. So this is optimizations, experimental duration, optimizations base duration, and these show up in the custom series here under metrics, and you can see that this is my base duration and my experimental duration. And because I'm using an aggregate, I have, not only do I have the live view, but I have that hour, day, and week roll up as well. And these are also streamed to the cloud dashboard because I've enabled them specifically. And if we jump over to the cloud dashboard, this gets a little bit tricky. I had to go into the metrics dashboard, and from in the metrics dashboard I had to create a custom graph, and you'll see that the custom graph here uses this optimizations base duration, and I actually have my base metric, right, which is my base duration, and I have my experimental metric, which is the experimental duration here. And so this creates that custom graph, so now I can watch the relative performance of these two processing branches over time. I also was able to add that to the graphs here. So for example, I can add it here, but unfortunately it looks like the custom metrics don't keep up with the live view of the graph. So if I switch from live view to, like, say, last 30 minutes, you'll see that I get that heavy processing. So again, I can graph those metrics against the other types of information here, CPU, memory, JDBC activity, and so on and so forth. But you'll see that this stops here at 10:46, and I'm currently at 10:48. So I think It's just the streaming process is not quick enough to stick to the live view or to keep up with the live view. So just keep that in mind. And then that's basically it. This was a lot of trial and error, so again, hopefully didn't get anything wildly wrong here. Let me jump back over here to see if there's anything that might be super interesting to see in terms of the exploration. I don't think so. I think I basically outlined it all. So yeah, I'm pretty excited about FusionReactor and at least having this deep dive here, or somewhat deep dive into the FusionReactor API object will give me enough information that I can start to segment and instrument my request processing, especially within the context of feature flags and experimentation. And if you have any ways to use the FRAPI, please let me know. I'm all ears and I'm excited to learn. And I don't know, I'm excited about FusionReactor and Cold Fusion and Lucee and the future. So party on.